Hello, everyone. Today, I'm going to explain my paper, the targeted full-state injection attack against DC state estimation without non-parameters. Please remember that in this paper, we will act as the intruder here. So first of all, let's go to the introduction part. Just like the computer system, the power system are also subject to the cyber attack due to the vulnerability of the communication networks. The false data injection attacks is an important class of cyber attacks. False data injection attacks can corrupt the readings of power sensors, thus causing system operators to receive false measurements and then perform incorrect operations. Although the state estimation is used to detect incorrect measurements, it cannot recognize and eliminate well-designed false state injection attacks. So in this paper, I would like to introduce a novel false state injection attack model against DC state estimation. Our model requires no network parameters and only use limited phase measurements units data. Also, our full state injection model can target specific states and launch large deviation attacks using the estimate non-parameters. So let's go to the background part here. So the state estimation is formulated as a linear equation below. The measurement Z could be the active power, reactive power, or anything else. And the state variables in power system should be the current or voltage or some like the switches. Then the best estimate state vector X hat could obtain through the least square estimation below. Then the bad data detection is used to test whether there exist bad measurements in power system. So if the residual is larger than a predetermined threshold, then our power operators may believe that there exists some bad measurements and they will eliminate that. So what should we do to launch the false state injection attack? We want to fool the power operators that the estimated state vector is expect instead of X. We should, as the intruder, we should replace original measurement Z with a fake one, Z-bad, right? So if Z-bad is well designed, then power operators will obtain incorrect power states X-bad, and it can bypass the bad data detection. So goes to the methodology part. Different from the previous work, in our work here, we need to consider the dynamic node, i.e. the load powers are literally experiencing fluctuation. You can see here, you can see the fluctuation along the time. Thus, we make the common assumption that the load powers are perturbed by the independent Gaussian variations from their static load power consumption, PIS. So by linearizing the load equations around the steady states in attacking regions, you can obtain the matrix forms. As you can see that the value of state theta here can be obtained by the PMU measurements. The system matrix A corresponding to a scaled Jacobian matrix carries significant information about the time constant part and net parameters. Thus, we can apply the regression theorem here for multi-dimensional Ornstein-Uhlenbeck process to estimate the state matrix A. After getting rid of the time constant, intruder finally can obtain the net parameters needed for the full state injection attack. So in summary, the algorithm can be formulated in this way. As step 1, we need to choose one target bus T and determine the attacking region omega A. Next, we need to collect the voltage measurements for all buses inside the attacking region and the current phasor measurements only for the target bus T. Third, we need to calculate the estimated matrix A here through the equations. Then we can estimate the time constant here, and after getting rid of that, we can obtain the line admittance Bij here. And finally, in step 6, given the target and malicious phasors, we can design attack vectors A here through the equations. So please refer to the results. You can see, as you can see here, our method can obtain the estimated values are really close to the true values here. So which means our method can estimate 9 parameters in a really close way. Then after launching the forced injection attack, you can see that the angle of bus 15 changes from 2.4 to 9.5, which means our forced injection attack succeed. And finally, please look at the picture 3 and picture 4 here. As you can see that the probability to bypass the bad data detection for different attacks and even the AC estimation is really high, which means our method is really robust against DC estimation and even AC estimation. So in sum, a novel forced injection attack model against DC estimation is proposed in this paper. Based on intercepted PMU measurements, our method can target specific states without any pre-knowledge of 9 parameters. That's all. Thanks.